Again, we're talking about as limit approaches infinity. Remember, infinity is a direction. It's not a destination that you can ever reach. So as we have the limit approaches positive infinity, the limit approaches negative infinity, 1 over x goes to 0, 1 over x goes to 0, and we came up with our theorem. Now, we talked about that in class, so that should be fairly straightforward. If not, come and see me and we'll go over it. Well, we got a few of our examples done, and what we did was we said that we were going to divide the top and the bottom by the highest power of x in the denominator. Because if you take a look, if we try to figure it out directly, we're going to get infinity over infinity. So as x gets larger and larger and larger, x squared gets larger and larger and larger, plus 2 gets larger and larger and larger, over top of 2x squared is getting larger and larger, and you end up with this idea of infinity over infinity, which is a problem. But instead what we'll do is we'll divide the numerator by x squared, we'll divide the bottom by x squared. That'll leave us with 1 plus 2 over x squared plus 2. We can then apply the limit. As x gets bigger and bigger and bigger and bigger, 2 over x squared gets closer to 0. Now once again, that's the idea of the bottom getting bigger and bigger and bigger and bigger. Let's make sure that we really understand that. If I have the limit as x approaches infinity of 2 over x, what's happening is as x gets bigger and bigger and bigger, this is getting bigger and bigger and bigger. So ultimately you're getting 2 over a bigger and bigger and bigger and bigger and bigger and bigger number, which ultimately is approaching 0. Okay? So looking at the next example, we have 3x cubed minus 2x over 5x cubed plus 3. We're going to divide top and bottom by the largest power of x in the denominator, which was x cubed. Left us with 3 minus 2 over x squared, 5 plus 3 over x cubed. It ends up with 3 over 5. Once again, what would happen if you tried to do this directly? You'd end up with infinity. Subtract a smaller infinity, so the top is infinity. You end up with infinity, and you end up with infinity over infinity, which is not a good thing. Over here, so if we try to do it directly, you're going to get negative infinity in the top, you're going to get negative infinity in the bottom. The only difference is it's going to be a little bit behind this one, but in terms of division, that's not going to matter much. So what we're going to take a look at is dividing the top and the bottom by x. We're going to be left with 1 over 5 over x plus 1. Allow x to get closer and closer and closer to negative infinity, and you notice that this whole thing becomes 0, and it works out to 1. There was a hint here that said determine the common denominator first, and you certainly could do that. Your common denominator would be x is an element, or sorry, the limit as x approaches negative infinity would be 6x cubed minus 1 all over x cubed. And you could work that out if you wanted, divide top and bottom by x cubed, or I noticed that the limit of a sum is equal to the sum of the limits, so it's going to simply be 6 plus 0, which is 6. I believe we did this one in class. This was our last one. We took the limiting variable of x. We divide the top and bottom by it. It left us with 5x squared minus 2x plus 8 over x over 3 plus 4 over x. Allow the limit to get closer and closer and closer to infinity, so x is getting bigger and bigger and bigger. So this goes to 0, this goes to 0, which leaves us with 5, the limit as x approaches infinity, of 5x squared minus 2x over 3. Now what's happening here is as x gets bigger and bigger and bigger, this is getting bigger and bigger and bigger and bigger and bigger. This is getting bigger and bigger and bigger, but this is getting bigger much faster. So the difference between them is growing. Even though eventually it gets divided by 3, it's still growing. So use the assumption, let's try x equals 1. So then it'll be 5 minus 2. So the top is 3. So 3 divided by 3 is 1. That would be the answer. If x equals 2, it would be 4. It's going to be 20 minus 4. So now that's 16 on top divided by 3. If x equaled 3, it'd be 9, 45. 45 minus 6 divided by 3. You can tell that this is getting bigger and bigger and bigger and bigger. This infinity is actually getting bigger, much larger than this infinity. So what's happening is the difference between them is getting larger and larger and larger. So it becomes infinity divided by 3, which is simply infinity. Okay? Kind of a weird concept, but I think it makes sense. Over here, we're going to divide top and bottom by the largest power of x in the denominator. So it's going to be 3x cubed divided by x to the 4 plus 5x over x to the 4 over top of 7x3 over x to the 4 plus 4x4 over x to the 4. Reduce those, it's going to become limit as x approaches infinity of 3 over x plus 5 over x3 over top of 7x squared, over top of 7 over x plus 4. Allow the limit to happen, so the x is getting larger and larger and larger. That'll get smaller, that'll get smaller, that'll get smaller, leaving us with 0 over 4, which is a perfectly good answer of 0. Okay, flipping over. I got a few more to do. So this one, we've got a little bit of work to do here algebraically, I think, to make it make sense to us. So I think what we'll do is, I'm just going to zoom in a little bit here. I think what I'm going to do is I'm going to take this, it's going to be the limit as x approaches infinity, x squared plus 2x plus 1 over top of 3x squared plus 3x. Divide top and bottom by the largest power of x in the denominator. So it's going to be x squared divided by x squared plus 2x divided by x squared plus 1 over x squared over top of 3x squared over x squared plus 3x over x squared. That'll be the limit as x approaches infinity of 1 plus 2 over x plus 1 over x squared over top of 3 plus 3 over x. What we end up with is 0, 0, 0, and a final answer of 1 over 3. Over here, let's see what we've got cooking. Okay, so we're going to divide by the largest part of x in the denominator. X over x squared over x squared plus 1 over x squared. Limit as x approaches negative infinity is going to be 1 over x over top of 1 plus 1 over x squared. And again, that's going to give us 0, 0, final answer of 0. And what does that mean? What does all of this mean? Well, what it means is that this, oh, you can't see. I went all the way through there. I should be checking. I'm sorry. So we've got this, and there we go. I should back out a little bit so that we can see it better. There we go. And what does this mean? This means that if I was to take this function, and if I was to graph it, as x got more and more negative, so in other words, as x is approaching negative infinity, you would notice that the range values would be approaching 0. Now, I don't know if it's approaching above or below at this point. I just know that you've got what's going to be a horizontal asymptote there. So at the y equals 0 line, you've got a horizontal asymptote at that extreme of the curve. On this one over here, what would be going on is if I was to take this as a function, and if I was to graph it over here, and as x got closer and closer to positive infinity, you would notice that it would get closer and closer to the horizontal asymptote of y equals 1/3. Once again, I have no idea whether it's coming from above or coming from below, but I know that that's what's happening. So that's what we're getting ready for in this. This is kind of an interesting question around here. We're going to use logic. So I've got x approaching infinity of 3 to the x. So as x gets bigger and bigger and bigger and bigger, 3 to the x is going to get bigger and bigger and bigger, and the whole thing's going to keep getting bigger and bigger and bigger. This is kind of interesting. What I would do is put it in a form that I could work with, which is that. So now as x is getting bigger and bigger and bigger, 5 to the x is getting bigger and bigger and bigger, which means that 1 over a bigger and bigger number is approaching. You got it, 0. This one's got a little bit of a sneaky part to it. See the negative here? If I was to put in negative numbers up here for x, wouldn't that be the same as if I decided to put in positive numbers here, but made sure that they were negative once they showed up there? Well, it sure would. In which case, this would be the limit as x approaches infinity of 1 over 7 to the x. Once again, as x is getting bigger and bigger and bigger, this is getting bigger and bigger and bigger, which means 7 to the x is getting bigger and bigger and bigger, which means 1 over a bigger and bigger and bigger number. You got it, equals 0. Well, ladies and gentlemen, that's all.